All right, strap in, everyone. We're going deep into Amazon S3.
Yeah, the service that's basically the engine of the internet.
But we're going beyond the usual how to make things big conversations.
Right.
Today, we're finding out how S3's scale actually makes it better for you, for me, for everyone using it.
We're going to be unpacking a talk from reInvent 2024
Oh, nice.
by two S3 engineers, Seth Markle and James Bornholtz.
Cool.
They gave us a peek behind the scenes at how S3 works at such a massive scale.
So less textbook, more like aha moments.
Absolutely.
Let's get into it.
Let's start with something most people don't really think about. The physical limitations of storage.
Okay.
Those hard drives that are in data centers, they're not magic.
Okay, you've got my attention. I actually haven't thought about the physical limitations of, the data.
So it's all physics, right?
Okay.
Hard drives have these spinning platters.
Uh-huh.
An arm has to move to find your data. The time it takes to locate and read that data is impacted by how fast that platter's spinning
Okay,
and how fast that arm can move back and forth.
gotcha.
So even individually, it's a relatively slow process.
Okay, so then how does S3 handle that inherent slowness when you have millions of users accessing data at the same time?
So this is where scale comes in.
Mhm.
Imagine you have one user, like Fina now.
Okay.
They need to process tons of data very quickly. We call that a bursty workload.
Bursty.
For them to get the speed that they need on a single hard drive, it would seem like they need a drive that's 100 times bigger than their actual data
Oh, wow.
just to handle those peaks.
Okay. That seems wildly inefficient.
It would be wildly inefficient.
Yeah.
But S3 handles millions of diverse workloads.
Right.
All those different customers, all doing different things.
Yeah.
What happens is all of those peaks and valleys average out,
Uh-huh.
and you get this surprisingly predictable pattern of what we call data temperature.
Oh, interesting. Data temperature, like how hot?
How often different data gets accessed.
Okay, gotcha.
So some data is very, very hot.
Uh-huh.
It's accessed all the time.
Makes sense.
And some is very, very cold.
Yeah.
It's archival.
Right.
It's rarely accessed.
Okay, so it's like rush hour traffic versus like a quiet Sunday drive.
Exactly, yeah.
Okay.
So because S3 can predict that data temperature
Okay.
across its entire system,
Uh-huh.
it can efficiently share resources.
Right.
So you, as a user, benefit from the throughput of many more drives than you're actually using.
So it's like I have access to this like high-speed data highway even if I'm in a small car.
Precisely.
Yeah.
Okay, cool.
And S3 keeps things running smoothly by constantly rebalancing the data across this huge network of drives when they bring a new storage rack online.
Wow.
We're talking racks that hold 20 petabytes each.
20 petabytes. How much data are we talking about here?
And
Can you give me a sense of scale?
think about storing the entire Library of Congress
Okay.
twice.
That's 20 petabytes. They actually have to reinforce the floors in the data centers
Oh my gosh.
just to support these racks.
Okay, so how do they integrate these racks
Yeah.
without causing like a slowdown for everybody?
Yeah. So they strategically migrate cooler data
Yeah.
to that new rack,
Uh-huh.
and they fill it up to about 80%. This frees up space on the older,
Right.
more active drives.
Gotcha. So it's like creating an express lane by like moving the slower traffic to a different route.
Yeah, exactly.
Okay, so it's this constant dance of like data moving around
Yeah.
to optimize.
That's a great way to think about it, yeah.
Okay. Fascinating. But then how does S3 make sure that my data like isn't stuck behind some like huge data processing job?
Right, so that's where shuffle sharding comes in.
Shuffle sharding. That sounds like it's straight out of a casino.
It's more like shuffling a deck of cards,
Okay.
with each card representing a piece of data.
Uh-huh.
So instead of putting similar data together,
Okay.
S3 spreads it randomly across its entire system.
So it's about preventing those noisy neighbor problems.
Exactly.
Where one person's activity impacts everybody else.
Exactly. Think of it like traffic lanes again.
Okay.
Shuffle sharding is like having tons and tons of lanes.
Okay.
So there are no bottlenecks.
Gotcha.
Keeps everything flowing smoothly.
Okay, so this is making sense to me now. So is it truly random, or is there like a method to the madness?
There's definitely a method.
Okay.
The initial placement is random.
Uh-huh.
But S3 uses this clever algorithm called the power of two choices.
The power of two choices. Okay, that sounds pretty technical.
It's like, think about being at the grocery store.
Okay, yeah.
You're trying to pick the shortest checkout line.
Right, right.
You quickly scan 2 lines and choose the shortest one.
Yes.
S3 does something very similar.
Okay.
So when it's assigning data to drives, it'll pick 2 at random
Uh-huh.
and then choose the one with more free space.
So it's balancing randomness
Yeah,
with real-time capacity awareness.
that's right. Yeah.
Clever.
Yeah.
So how does this play out in practice?
So shuffle sharding happens at multiple levels
Okay.
within S3.
Uh-huh.
So we've got like distributing data across drives,
Right.
directing requests to the right servers.
Okay.
It even happens like at the DNS level, the domain name system.
Gotcha.
So when you make a request, it's not just going to one specific server.
Right.
It's being distributed across multiple servers.
Okay. So this multi-layered approach, that's how S3 ensures I get consistent performance no matter what else is going on.
Precisely. It's all about that concept of decorrelation,
Okay.
preventing your requests from being affected by other users' activities.
So no matter how much data someone else is uploading or processing, my experience is like smooth and predictable.
Exactly.
Gotcha.
But we're not done yet.
Okay.
There's another fascinating aspect of S3's scale that we need to unpack. How embracing the possibility of failure.
Wait, what? Embracing failure? How can that possibly be a good thing?
Get ready for this. S3 is designed to be fault tolerant,
Okay.
meaning it can handle failures gracefully.
Mm-hmm.
This allows engineers to be bolder.
Okay.
They can roll out new features, new hardware,
Yeah.
more quickly
Right.
and with less risk.
Okay. This sounds like the exact opposite of how most systems are built. So how does this fault-tolerant design actually work?
So it all starts with a technique called erasure coding.
Okay.
Imagine you have a file that you want to store.
Mm-hmm.
With erasure coding, S3 breaks that file into multiple pieces, we call them shards,
Shards.
and it adds some extra parity shards
Parity shards.
using some clever math.
That's complicated.
They're like backup pieces.
Okay.
The magic of erasure coding is that any combination of a certain number of these shards can reconstruct the original file.
Oh, cool.
So even if some shards are lost, like say a hard drive fails,
Right.
S3 can still recover your data.
So it's like a really efficient backup system
Yeah.
where instead of copying the whole file multiple times, it's just storing these shards strategically.
Exactly.
Okay.
Erasure coding allows S3 to achieve high data durability with much less storage overhead compared to simple replication.
So what does that mean for the engineers who are working on the system?
This means they can experiment
Okay.
with new hardware
Uh-huh.
or software components
Right.
without this like fear of a catastrophic failure.
So it's like they've got this safety net and they can try new things without being afraid that they're going to like break everything.
That's a great analogy, yeah.
Okay. Cool. So this safety net allows them to move faster.
Yes,
That's
they can
fast.
try new things,
Uh-huh.
knowing that the rest of this system can compensate if something goes wrong.
This is amazing. It's like embracing potential failure leads to this more resilient and innovative
Yeah,
system.
that's the idea. Yeah.
Okay. But how does S3 handle larger scale failures? Like, what if a whole data center goes down?
So that's where S3's multi-layered approach to redundancy comes in. Remember that erasure coding?
Yeah.
Well, those shards are distributed not only across multiple drives,
Right.
but also across different availability zones,
Availability zones.
which are essentially separate data centers.
Okay.
They're intentionally isolated from each other.
Gotcha.
So if one goes offline, the others can keep running.
So even if a whole data center goes offline, my data is still safe and accessible.
Exactly.
Wow. This multi-layered redundancy, that's a key part of what makes S3 so reliable,
Yeah.
even in the face of these unexpected events. And we're going to dive deeper into that
Yes.
right after a quick message.
Welcome back to our deep dive into Amazon S3 scale. Before the break, we were talking about how S3 protects your data, even if a whole data center goes offline.
Yeah, it's kind of mind-blowing to think about these huge data centers
Yeah.
and all the things that could potentially go wrong.
Yeah.
So how does S3 actually make sure that, like, my data is safe even in those worst-case scenarios?
So it's all about thinking ahead, right?
Okay.
S3 is designed to handle failures not just at the individual drive level,
Okay.
but also at the rack level,
Rack level.
where an entire rack of servers might experience a power outage
Oh, wow.
or a network issue.
Okay, so we're not just talking about a single hard drive failing, but like these larger events that could impact a bunch of hardware at once.
Exactly.
Gotcha.
And then, of course, there's the possibility of an entire availability zone going down.
Right.
Remember, those are like separate data centers.
Yeah.
They're intentionally isolated from each other so that if one goes offline,
Right.
the others can keep running.
So we're talking about like multiple layers of potential failure.
Yes.
Individual drives, racks of servers,
Ah,
even whole data centers.
yep.
So how does S3 plan for all of that?
So redundancy and careful engineering are key.
Okay.
You know that erasure coding we were talking about?
Yeah.
It plays a huge role here. By breaking the data into those shards and distributing them across multiple drives and availability zones,
Huh?
S3 can reconstruct your data even if an entire data center goes offline.
So it's like having backup copies of my data spread out in different physical locations?
Yeah.
Even if one location is completely destroyed, my data is safe in the other location.
That's a great way to think about it.
Okay, cool.
And this redundancy isn't just about hardware failures.
Oh, okay.
It helps S3 handle software bugs or other unexpected issues too,
Oh, that's interesting.
because the system is designed to be fault tolerant.
Right.
Engineers can roll out new software updates
Huh?
or even experiment with entirely new storage technologies
Wow.
without risking the integrity of user data.
It's like they built this incredible safety net so they can innovate without worrying about breaking everything.
That's a great way to put it, yeah.
Cool.
And this fault-tolerant approach is, deeply ingrained in their engineering culture. It's not just about the technology, but how the teams think about building and operating the system.
Mhm.
They're constantly testing,
Okay.
simulating failures,
Right.
monitoring everything to make sure that S3 can withstand whatever challenges come its way.
So it's like they're constantly asking, what if this fails?
Yeah.
And then making sure the system can handle it.
Exactly. And this constant focus on fault tolerance makes the system much more resilient. It even helps with those noisy neighbor problems we talked about earlier.
Right.
If one user's workload suddenly spikes,
Right.
or if there's a hiccup on a particular server,
Yeah.
the rest of the system can compensate, and you probably won't even notice.
So this focus on handling catastrophic failures actually makes the system run more smoothly on a day-to-day basis.
Exactly, yeah.
Interesting.
And here's another interesting thing.
Okay.
This fault-tolerant design actually enables S3 to evolve and innovate more quickly
Oh, okay. How so?
because they can test new ideas in this safe, controlled environment. Engineers are free to try new things.
Yeah.
They can push the boundaries without fear,
Uh-huh.
knowing that the rest of the system will keep humming along.
That's fascinating. It's like a built-in lab where they can experiment without the risk of breaking something important for users.
Exactly, yeah.
Cool.
And it's a big part of how S3 has been able to stay ahead of the curve,
Uh-huh.
constantly improving its performance, its reliability, and its features.
Makes sense.
But there's a subtle aspect to this fault-tolerant design
Okay.
that often goes unnoticed.
Oh, I'm intrigued. Tell me more.
One of the biggest challenges with a system at this scale is knowing when something has failed.
Oh, okay.
It sounds simple,
Yeah.
but in a system with millions of components spread across multiple data centers,
Right.
it can be really tricky to distinguish between a temporary glitch and a real failure.
I see what you mean. In a smaller system, if something stops responding, it's probably broken.
Yeah,
But with S3, a temporary hiccup might look like a failure even if it's not.
exactly, yeah.
Wow.
And that's why S3 has this sophisticated system for monitoring and detecting failures.
Okay.
It's constantly scanning every byte of data,
Wow.
checking for inconsistencies, errors,
Uh-huh.
and it has a whole set of alarms and alerts that notify engineers if something suspicious is happening.
So it's like a high-tech security system that's always on the lookout for trouble.
That's a good way to think about it, yeah.
Okay.
And this proactive approach to failure detection allows engineers to respond to issues quickly,
Right.
often before users even realize anything is wrong.
It's amazing how they can keep everything running smoothly behind the scenes so that users like me never even see those bumps in the road.
It's a testament to their skill and dedication.
Mhm.
And remember that erasure coding we discussed?
Yeah.
It's not just about redundancy.
Okay.
It also makes the system more resilient to these temporary glitches,
Oh, okay.
because any combination of a certain number of shards can reconstruct the original data. S3 can tolerate some level of failure without impacting your experience.
So even if some shards are temporarily unavailable, the system can still function normally.
That's right.
Gotcha. It's like having multiple backup singers ready to step in if the lead singer loses their voice.
Exactly, yeah.
Cool.
And this ability to gracefully handle temporary failures is a big part of what makes S3 so reliable.
This is fascinating to see how all of these pieces fit together to create such robust and reliable system. So we've explored the physics of data, the magic of shuffle sharding, and the surprising benefit of embracing failure.
Yep.
What else did these S3 engineers tell us at Re.Invent?
So they delved into another really fascinating aspect of how S3 handles its vast scale. It's this concept of decorrelation as a core architectural pattern.
Decorrelation. Okay, no, that sounds like a technical term.
Yeah.
That's about to become surprisingly relevant to my everyday use of S3.
You got it. So decorrelation is all about making different parts of the system independent of each other, so that a problem in one area doesn't cascade and impact other areas.
Okay, so it's about creating these like separate compartments within the system
Uh-huh.
to prevent a single point of failure from bringing the whole thing down.
Precisely, yeah.
Gotcha.
And this concept of decorrelation is applied throughout S3,
Okay.
from the way data is stored on drives to how requests are handled by servers.
Okay.
It's one of the key principles that allows S3 to operate at such a massive scale while remaining reliable and performant.
So we talked about spreading data across multiple drives using shuffle sharding. How does decorrelation factor into that?
Yeah, so it starts with how S3 decides where to store your data when you upload a file.
Okay.
Instead of assigning it to a specific drive based on some predetermined logic, S3 uses randomness to distribute data across its entire fleet.
So it's not about putting all the similar data together.
Right.
It's more like shuffling a deck of cards and dealing them out randomly to different players.
That's a great analogy. And this random distribution is key to decorrelation. It ensures that no single drive becomes a bottleneck for any particular user or workload.
Right.
Even if one drive experiences problems, the other drives can pick up the slack without impacting overall performance.
So it's like having multiple routes to get to the same destination. If one road is blocked, you can just take a different one and still arrive on time.
Exactly. And this redundancy at the storage level is just the beginning.
Oh, okay.
S3 applies the same concept of decorrelation to how it handles requests from users.
Oh, interesting.
When you send a request to S3, it's not routed to a specific server.
Okay.
It's randomly assigned to one of many servers,
Okay.
each capable of handling any request.
So it's not like calling a specific customer service number and hoping the right person answers.
Right.
It's more like sending a message to a general inbox where any available agent can help you.
That's a great way to put it.
Okay.
And this approach prevents any single server from becoming overwhelmed by requests,
Gotcha.
even during periods of, heavy usage. It also means that if one server goes offline, other servers can seamlessly take over without any interruption to users.
So it's like having a team of customer service agents, each trained to handle any type of inquiry.
Yeah.
No matter who you talk to, you'll get the same great service.
Precisely.
Cool.
And this approach to request handling is made possible by another key aspect of S3's architecture: statelessness.
Statelessness.
The servers that handle requests, they don't store any persistent state information about user data.
Okay.
This means any server can handle any request regardless of where the data is stored.
So it's not like those old school systems where you had to call a specific department to get help with a specific issue.
Right.
With S3, it doesn't matter who you talk to.
Oh,
You
yeah,
can all access all the information and provide the assistance you need.
precisely. And this statelessness is crucial for achieving S3's high levels of scalability and reliability.
Okay.
It allows them to easily add new servers to the system,
Uh-huh.
distribute requests evenly, and tolerate server failures without any impact on your experience as a user.
So it's like a well-oiled machine where all the parts are interchangeable.
Yeah.
And can work together seamlessly.
That's a great way to visualize it.
Okay.
And this brings us to another fascinating technique that S3 uses to achieve decorrelation:
Okay.
DNS shuffle sharding.
DNS shuffle sharding.
Got it.
Okay, we've shuffled data.
Yeah.
We've shuffled requests.
Yep.
Now we're shuffling DNS.
Exactly.
Intrigued.
So remember that when you access a website,
Uh-huh.
you typically type in a domain name like Amazon.com or Google.com.
Right.
Your computer then uses DNS, the domain name system,
Uh-huh.
to translate that domain name into an IP address,
Right.
which is like a numerical street address for computers on the internet.
Right, so DNS is like the phone book of the internet. You look
Yeah.
up a name, and it gives you the corresponding number.
Exactly. And with S3, this DNS lookup process is used to implement yet another layer of decorrelation.
Oh, interesting.
So when you send a request to S3,
Mm-hmm.
the DNS system randomly assigns you to one of many front-end servers.
Okay.
each responsible for handling a portion of S3's traffic.
So even before my request reaches an S3 server, it's already being shuffled around
Yep.
to ensure that it doesn't overload any specific part of the system.
Exactly. This DNS-level shuffling has several benefits.
Okay.
First, it distributes traffic evenly across S3's front-end servers,
Okay.
preventing bottlenecks and ensuring consistent performance.
Right.
Second, it isolates users from each other.
Okay.
So heavy usage from one user doesn't impact the experience of others.
Okay. So it's like having multiple entrances to a large stadium. Even if one entrance gets crowded, the others can still handle the flow of people smoothly.
That is a great analogy.
Okay.
And finally, this DNS shuffle sharding is crucial for fault tolerance.
Okay.
If one front-end server goes offline, the DNS system can simply direct requests to other servers,
Right.
ensuring uninterrupted user access.
So it's like having multiple backup quarterbacks ready to step in if the starting quarterback gets injured. The game can keep going without missing a beat.
Exactly. All of this shuffling and redundancy happens behind the scenes,
Right.
so users never have to worry about it.
Right.
They simply experience a fast,
Mm-hmm.
reliable storage service
Yeah.
that always works.
It's incredible how much complexity is hidden beneath the surface of S3.
Yeah.
It's like this perfectly choreographed dance with every step planned to ensure this like seamless and flawless performance.
Yeah, it's really amazing.
I'm sure there's even more to the story though, right?
You bet.
Yeah.
We've only scratched the surface of how S3 leverages its massive scale to optimize performance. We'll continue our exploration after a quick message.
Welcome back. It's been quite a journey behind the scenes of Amazon S3.
It has.
I'm starting to get it now, how all of this complexity actually makes things better for users like me.
Yeah, and we haven't even touched on how S3 uses its scale to really squeeze out every bit of performance. It's not just about handling lots of data. It's about handling it efficiently.
So it's not just about size, it's about speed too.
You got it. One key technique is something we talked about before, erasure coding.
Okay.
Breaking the data into those shards.
Right.
It not only makes it more resilient,
Mm-hmm.
it also opens up these cool opportunities for making things faster.
Okay, remind me again how those shards actually boost performance.
Okay.
Does just having more pieces of data make it faster to access?
It's not about the quantity of shards, but the flexibility they provide.
Okay.
Remember, to reconstruct the data, S3 only needs a certain number of shards.
Right.
It doesn't need all of them.
Okay.
So this means it can be picky about which shards it reads from.
So it's like I have multiple backup singers, but I only need a few of them to hit the high notes.
Yeah,
I can choose the best ones at that moment.
that's the idea.
Okay.
S3 is constantly monitoring all of its drives. And when it needs to read data, it can choose the fastest drives at that moment.
Oh, interesting.
So this helps to avoid bottlenecks
Uh-huh.
and reduces that lag time.
So it's like having a real-time traffic report for the whole S3 network, allowing it to just route around any congestion.
Exactly.
Oh.
And this dynamic shard selection works because of that random distribution
Okay.
from shuffle sharding.
Right.
Because the data is spread out so evenly, S3 has a lot of options when choosing which drives to read from.
So it's like having multiple lanes on a highway, and S3 can pick the fastest lane at any given time.
Exactly.
What happens if there is like an unexpected slowdown, like a drive is hiccuping?
That's a great question. That's where speculative reads come in.
Speculative reads. All right, now we're getting fancy. What is that?
So let's go back to how S3 breaks data into those shards.
Okay.
To rebuild your file, S3 needs to read a certain number of them.
Right.
But what if one of those shards is on a drive that's acting up? Well, that would slow the whole process down.
Right. We don't want to be held back by one slowpoke.
Exactly. So S3 will start reading from a set of shards that it thinks will be the fastest.
Okay.
But at the same time, it starts reading a few extras, just in case.
Oh, clever. So it's like having a backup plan ready to go if the first option falls through.
Precisely. If one of those initial shards is slow, S3 can just ditch it
Okay.
and use one of the speculative shards instead.
Oh.
So this helps to ensure that you get your data as quickly as possible,
Right.
even if there are a few hiccups along the way.
Like a race car with a pit crew that can just swap out tires at a moment's notice.
Exactly. And this technique works especially well with erasure coding because, again, S3 only needs a portion of the shards to rebuild the data.
Okay.
It can be more aggressive with its speculative reads, knowing that it only needs a few to succeed.
So it's like one of those movies where you've got multiple teams searching for the same treasure, and only one of them needs to find it for the mission to be a success.
Perfect analogy. And the best part is all of this is happening behind the scenes.
Right.
Users don't have to worry about shard selection or speculative reads.
Yeah.
They just see this fast, reliable service that always delivers.
This has been amazing. I mean, we've really gone deep into S3.
We have.
From those physical limitations of hard drives to these mind-boggling techniques for optimizing performance.
Yeah.
It's clear that scale in S3 is so much more than just a big number.
It really is. It's about taking those big numbers and turning them into a system that's resilient, efficient, and always pushing the boundaries of what's possible.
It really is amazing how all this complexity comes together to create a seamless experience for us, the users. So next time I'm uploading a file to S3 or, accessing my data, I'll remember there's this whole world of innovation working behind the scenes,
Yeah.
making sure my data is safe, accessible, and always there when I need it.
That's right. And if this deep dive has sparked your curiosity, there's so much more information out there about S3's architecture and design.
Oh, yeah.
The more you learn, the more you'll appreciate the sheer brilliance of this incredible system.
This has been a real eye-opener. Thanks for joining me on this deep dive.
It was my pleasure.
Until next time, keep exploring and keep that data flowing.